Welcome all of you. We will have a discussion about Pinacolone rearrangement with some examples in this video. So this is Pinacolone rearrangement. So this is uh, Wilhelm Rudolf Fittig, who is discovered this Pinacolone rearrangement, and he is known for Fittig reaction. This Fittig reaction is known for. So this is the simple Pinacol, and this is the Pinacolone. So what is the definition here? Conversion of 1,2 diol into carbonyl compounds in the presence of acid. So this is the simple uh, reaction that he has pointed out. And another definition of the same thing, acid catalyzed rearrangement of vicinal diol to carbonyl compounds with the elimination of water is called Pinacolone rearrangement. So both the things are same only, but the way of giving the definitions are different. This may be useful for your examination purpose. And the conversion of an alcohol having two adjacent OH group, that's a Pinacol, into a keto, that Pinacolone, by a action of acid. So I'm giving you three different uh, definitions for your sake of convenience. So all are same. So vicinal diol is nothing but, see that this is the carbon 1, carbon 2 if you consider. Okay, adjacent carbons having a OH group, so that this is called vicinal diols. So from the butane, starting from 1, 2, 3, 4. So that 2, comma 3 is the next adjacent one. So the adjacent carbon having a OH group, which is called vicinal diols. So the simple Pinacol is example here, 2, comma 3 dimethyl butane, 2, comma 3 diol. And simple Pinacolone is 3, comma 3 dimethyl to butanone. So this is the simple conversion, Pinacol into Pinacolone in the presence of acid with a mild heating, which will result into the conversion. So again, I am pointing out here the details properties of our Pinacol and Pinacolone. And as already I pointed out that the German chemist Wilhelm Rudolf Wittig discovered this reaction in 1860. And this Pinacol is a compound which is having two hydroxyl group attached to a vicinal carbon atom. This is already I have given you. This is a vicinal carbon. These diols. Okay, this is called our uh, hydroxy group presence there, so that this is 1, comma 2 diol. And it is an organic compound having white in color. And Pinacolone is an important ketone. It has peppermint or camphor like odor and appears to be colorless liquid. And I mentioned you the 3, comma 3 dimethyl 2 butanone is an example, IUPAC name for the Pinacolone. So this is the general reaction. General reaction is a Pinacol is converted into Pinacolone in the presence of acid. This is a general reaction, and this is the mechanism. Mechanism is involving four different steps. Step one: protonation by acid. So the acid is reacts with the either one of the diols and getting protonated, and removal of the water to make a tertiary carbocation. Methyl shift takes place, followed by here 1, comma 2 shift also we can consider, because some more example give you making you to different groups may migrate from one place to another place. So shift of a group is takes place, or 1, comma 2 shift is taking place in the third step, and protonation result into the deprotonation result into the Pinacolone. Now see the mechanism here. For the sake of convenience, just we make it like this: the Pinacol here, the CH3, 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 CH3. Okay, and this is OH, this OH here. Now the step one already we have pointed out that protonation. The protonation takes place here to make a compound H2O plus here come over here. Now the loss of water or removal of water. So what the water moiety is going out, so that the positive charge goes to the carbon to make a carbocation here. Now the carbocation, once it forms, this methyl is migrated to this side to make a See, this methyl group migrate to this one, and so that the positive charge migrate to this side. So as a result, we are getting a tertiary carbocation here. So this is the stable one than this one. After the process of this carbocation is taking place, the OH group here, deprotonation is the fourth step. So the deprotonation takes place. So the OH here, this bond goes to the carbonyl carbon to make a pinacolone. By loss of this plus and H goes as a minus H plus. As we already pointed out that this is a acid is a medium for the reaction. So that H plus ion is started here and it is cleaving out in the reaction by deprotonation. So that this reaction is simply conversion of a pinacol into pinacolone. And more often, the stereochemistry says that is a regioselectivity. What is a regioselectivity means? Either the bond breaking or bond making. It must be in one direction. In all other possibilities are there. If suppose the possibilities, two or three possibilities there, this goes only this way only. So that the overall number of possible bond formation or bond breaking may be there. It prefers only one, so that is an regioselectivity. And more stable carbocation yields the major product. So this suppose we consider that this reaction is taking place. Why can't this may come over here to take it the carbocation and making a pinacolone? Why can't it go this to tertiary carbocation? So it may be migrating to the more stable one. So then compared to both, this is the more stable, so it prefers this one. Now we will discuss about some more examples on the Pinacol rearrangement. This is an symmetrical Pinacol here. Symmetrical Pinacol, why it is symmetrical Pinacol? See CH3 here, C6H5, C6H5, CH3OH. If I just break this one or cut this molecule, I can get a similar molecules like our Mosambi or any other like fruit. If I take it watermelon or Mosambi, if I break it, I will get two same pieces of this. So that is a symmetrical Pinacol. So symmetrical Pinacol, which gives you with H plus ions and heat the content, which will result in the Pinacolone in the normal stage of thing. The migration of phenyl group takes place during the rearrangement via 1, 2 shift takes place. We'll see the mechanism now. The mechanism says here, always keep remember that step 1 is a protonation, step 2 our removal of water, step 3 is the migration 1, 2 shift, and step 4 is the deprotonation. See that the H plus ions is goes to this one, either the one both are same, and one of the OH groups which is protonated to get our water moiety here. So H2O plus come over here. Removal of water, H2O is going out so that the positive charge migrate towards the carbon to make a carbocation. Now the 1, 2 shift is taking place so that the phenyl group is now shifting to this one so that the positive charge migrate to another one. So the another carbocation is formed here. Okay, C6H5, C6H5, CH3. So that and deprotonation takes place here. See your OH bond here, the single bond here, O and H having a single bond. This bond migrated toward this so that the Hn plus ion moves out from the reaction and make it as a carbonyl compound. So that we are making a enol into ketone. So that this is a pinacolone is coming over here. Now in the unsymmetrical pinacol, for example, CH3 CH3 pH pH. See that now I cut this molecule like this. Definitely this cannot match with this one, so that this is a unsymmetrical pinacol. So in the case of unsymmetrical pinacol, the migration 1, 2 shift takes place here also, but not a phenyl group. It is a methyl group. So if we'll see the mechanism how the pinacolone is formed via 1, 2 shift. This migration of methyl group then the phenyl group takes place during the rearrangement reactions due to resonance stabilization. Now see the mechanism here. The mechanism clearly pointed out that the step 1 always the protonation. Protonation takes the H plus ions goes to the um, OH group, one of the OH groups here, that OH group. Now H2O plus come over here, removal of water, that H2O goes out so that the positive charge migrate towards the carbon to make a carbocation here. Now this carbocation, due to the presence of these two phenyl ring presence here, make the resonance stabilized one. So resonance stabilization is there, but carbocation stabilization is different one. Okay. So here resonance stabilized so that the migration, the phenyl group is not going here or there. So it asks the methyl group to migrate here. So the migration of the methyl group takes place. So the methyl group is migrated here, so the positive charge migrated to the another carbon to make a another carbocation. Now, as usual, you have OH group here. The bond migrated towards to make a keto compound here. So H and positive charge, H plus ion minus H plus ion goes as a deprotonation. So it goes like this. So it will get a pinacolone. So the point to be noted here, in the case of the symmetrical pinacol, phenyl migration is there. Unsymmetrical pinacol, methyl migration is takes place. Now, in the case of cyclohexane system, so we are discussing about the cyclohexane system in the case of Pinacolone rearrangement. This is the example 1,2 dimethyl cyclohexane, 1,2 diol. So both the form are cis isomer. Okay. Cis isomer means see that CH3, CH3 are in the same fashion, OH, OH are in the same fashion. CH3, OH are in the same direction, or otherwise we can say this is a cis. If suppose this like bond maybe differs, OH with CH3 differs means that's a trans isomer. We'll discuss later this one. Now in the case of a cis isomer, the H plus ions is added to any one of the OH group. What will happen? Either here or here, the H2O plus may come. So removal of water goes to the positive charge towards the carbon to make our carbocation here, and methyl shift takes place here. Deprotonation of this place takes place to get our 2,2 dimethyl cyclohexanone. One kind of the pinacolone in the case of a cyclohexanone system. Whereas in the case of our trans isomer, what will happen in the case of trans isomer? See the trans isomer, I already pointed out that CH3, here CH3, the direction is differs. OH to OH direction differs. So that both of them in opposite directions. So that the opposite directions always know about that the cis means same direction, trans means opposite direction. Trans 1 comma 2 dimethyl cyclohexane 1 comma 2 diol on H plus ions. What will happen that if you consider about either the one? So if I am taking here the protonation takes place in this case. So protonation make you to H2O plus here. So removal of water in the second step make the positive charge goes to here. So in this case, the another carbocation takes place here by migration of this group goes to here, so that the ring contraction takes place instead of migrating directly to here. So this ring goes to here to make a 5 member. So once it goes here, 1 2 3 4 and 5, so the 5 member ring is formed. As usual, the methyl group here, and deprotonation takes place by the fourth step to make a our pinacolone. So the pinacolone here is 1 methyl cyclopentyl ethanone is an example in the case of our trans isomer. So cis isomer, normal, pinacolone is formed, normal reaction as usual, whereas in the trans isomer only make a compound into ring contraction takes place. So thanks for watching this video. Like it, subscribe it and share it for more number of videos. Thanks for watching. Thank you.